just not sure where it is. And then the other part of it too is that there are only so few numbers that when you multiply them, they end with a 1. Especially when they're squared numbers. So numbers that end with a 1, when you square them, is like numbers ending with 1, like 11, 21, 31, 41, 51, 61, 71, 81, going on and on, right? The other possibility is 9 by 9, 19 by 19, 29 by 29, 39 by 39, going on. So therefore, because it ends with a 1, is either the number must be either 41 times 41 or 49 times 49. But guess what? This is a little, 49 times 49 would be a lot closer to this number. So it wouldn't make sense for us to even use 49, because the number will be too big. But let us say we're never sure, right? Fine. We can trick the system. So what could we do if we wanted to find out what 49 times 49 would be? What we could do is we replace 49 with something else. Replace it with 50 minus 1 and 50 minus 1. That is, if you wanted to do it without, do it without calculator and still get it right, yeah? Now, when you get comfortable with the distributive property, doing this easy for do, right? Because you can square this number, square that number, and the middle is when you multiply this by this and then add it to itself, right? So 50 times 1, 50, 50 plus 50 is 100, right? But because it's a minus 1, you get what? Minus 50. So plus 50 is 100, minus 50 plus minus 50 is a minus 100, right? So therefore, the middle must be minus 100. Minus 1 times minus 1, that go be a plus 1. And then 50 times 50, that's what? That's a 2,500. So you subtract the 100 from the 2,500. So your answer is 2,401. And if you put that in your calculator, chances are that's what you're going to get. So if we multiply 49 by 49, the answer we get is 2,401. But I don't have a tablet, so I don't even know if I can. Come on, there we go. Alright, fine. Yeah. Okay. So obviously this is too far from that number. So the 49 by 49 never work. So make we use 41 times 41 then. Since the 49 never work, let's use the 41 instead. So let's use 41 times 41. That means we can replace it with how that would I go now? 40 plus 1. So I could write 40 plus 1. 40 plus 1. Now when I'm positive, it's nice because you don't have to worry about the negative signs, right? So 40 times 1, 40. 40 plus 40 is 80. So the middle term is going to be 80. 1 times 1, that's going to be 1. 40 times 40, this is 1600. So we'll put the plus sign here. plus sign here. Now, we add up all of that, we get what? We get that. Therefore, if we square root 1681, we're going to end up with this number, 41. Therefore, if I were to put now, I can say yeah, I can replace that with this. So 1681 is the square of 41. And of course, whenever that happens, yeah, you square root a square, you eliminate that sign. So therefore, this cancel that. So you can rub out all of that. And it leave you with just that. So yeah, and once you get here, you're in a good space, because this just means say is either you have 9 plus 41 or 9 minus 41. So if you really want to figure out what it means, just rub out this. That's one of your possibilities. Or rub out that, and that's another one. Obviously, you want the minus to be a little bit higher, right? Yeah. So those are the two possibilities. It is either 9 plus 41 or minus 41. That is what this sign means. So it's either 9 plus 41 or 9 minus 41. So now you can actually write you can write that two ways. So you have one on the left and one on the right. So you can have so I have this. Yeah. So let me move this a little bit. Yeah. So that is just the translation of what you were looking at earlier. So yeah, once you reach here, so you know you're not in a bad space. You're a lot closer to what you're supposed to do, right? 9 plus 41, 50 over 40. You just cross out the zeros. So this part will be 5 over 4. This are going to be minus 32 over 40. And you can divide 32 and 40 by 4. So you're going to end up with 8 over 10. And if you end up with 8 over 10, you can reduce that again. Right? 8 over 10, that's going to be, you divide them by 2, you get what? 4 over 5. So this are going to be 5 over 4, this is going to be minus 4 over 5. Yeah. I'm trying to remember if there's if there's anything else I'm forgetting. I don't know. But can always throw up another one of them. So let me see if I can find another one. I try to remember. Oh right, I have to look at the video. Oh, it's the video I need. Hold on, you know. Hold on. Oh, never mind. Found a paper with some of the what? Yeah, my tablet doing something weird, so I'm not even paying no mind right now because I madness that. Oh, okay, alright, this I don't want to use that. Alright, fine, I will use it. Anyway, so let's try this one. This obviously this a madness, but still, why not? Obviously that is implied, right? That it equal to 0. Yeah? Let me see. You know, I never tried that one before. I never tried that before. Like the other way around. Huh. Why not? You know what? I go, yeah, maybe do the other way around. Maybe do the other way around. Wait. I want to do that and see what that would have come out to. Let's see how uncomfortable we are with this. Minus what again? Right, this. Let me see if. Alright, we'll move that a little bit. Yeah. Alright, so we have that, and again, let me just, well, obviously because it's the other way around now. This is our C, this is our B, and this is our A. Right? So our B is going to be, no, why I said B? Our C is 56. Our B at 23, and our A is going to be a minus 63. Yeah. This honest, oops, sorry. Sorry about that. Yeah. This is the first time I'm doing it with the negative ax squared in terms of the quadratic formula. I completely square with it before, but never like this. Meaning using the quadratic formula, using this. Never quite did this one before. So let us see what becomes of that. Alright, hold on. Let me try to make that adjustment again. Alright, good. Alright, so again, with the madness that I come up with, I want to use minus b, b squared, minus 4ac, and 2a. Alright, so why not write them down? So we have minus b, minus 4ac, 2a, and of course we have b squared, right? So let us see what becomes of all of this. Oops, now I'm about a little bit further because might be a bigger number. Alright, hold on. No, let me bring them closer. So let me bring this a little bit closer. So minus 4 AC and the 2A here. Yeah. Alright, just one more adjustment here so that we, yeah, I want to see that a little bit better on that side. Alright, So what was our B again? Our B is 23. So minus 1 times B is minus B. Minus 1 times this, we'll have minus 23. So this is going to be minus 23. Obviously, no. We're going to have a square 23. Alright? So let me do that madness right here. Let's do it. Let's do it right in this little space, and then we can write back that. So we have 20 plus 3 times 20 plus 3. So 20 times 3 is 60. So let's add 60 to itself. That's 120. So the middle is going to be 120. Now, if you square 20, the first term is going to be 400. And then you square 3, the last term is going to be 9. Right? So if you add up all of this, then let me just move this again, just a little bit. Yeah. So therefore, the square of 23 is going to be 529. Right? So now forget that now. So we confident said that is 529. And we can always double check that. With the calculator and so on. Yeah? So we move this border back. Yeah. And then I go put back the 2A right here. Yeah. And then what is A? A is minus 63. So 63 plus 63, 126. So it will be minus 126. Now, for AC now. So you're going to have 63 times 56. Now, how could I use the prime numbers and solve that problem? 63 is 3 by 3 by 7. Obviously, I'm doing this a little bit off screen. Alright, so you probably can't see what I do. Then you have 2 by 2 by 2 by 7. Okay. Alright, there's no easy way to get this done. This is basically 72 times 49. So if you want to do that instead, but actually, I don't know why I say that. There is a way to do this, but there is a way to do that. You can do it similar to how we do the squaring of the numbers. So okay, because I know this out of my head, I'll soon write it back, right? I'll just write some rough work right to stand in. We'll soon put back the formula right here. So let us say I wanted to multiply 56 by 63. May I cheat the game again? 50 plus 6, 60 plus 3. Yeah, man. Sometimes we have to find a different way to do it, right? Now, obviously, we have to be careful. We have to literally do this, step by step. So 50 times 60, that's going to be 3,000. So we have 3,000 for the first number, right? So this times this, then this times that, right? So now we have 150 next. Then we have 60 times 6, which is 360. And then now we have 6 times 3, which is 18. So now we add up all of that, and we have an answer for that. So that look like 510 plus 18, so 528. So 3,528. Oh, wait. So let me see if what I did make sense. 63 times 56. Yeah. So all of that was not for nothing, right? When you add up all of that, you get 3,528, right? 510 plus the 18, 528, add it to this, you get 3,528, right? So, but again, we have to be careful, yeah? We have to be careful. The A is minus 63, right? The A is minus 63. So, it obviously means that when we multiply the 63 by the 56, whatever happened, that this number out here so go end up becoming positive. Alright? Because if you multiply minus 63 by 4, you're going to end up with a positive 252. And then you just multiply that by the C. 252 by the 56. But anyway, we already have the 3,528. So we'll just go add that to itself and then add that to itself again. So, hold on there. We'll do that. So, when we add that to itself, we get 7,056. And then we add that to 7,056. Yeah. Now, let me just make sure say that part makes sense, right? So even though I go write it down, I go double check it so that it makes sense, right? So now let's multiply 63 by 56 by 4. Yep. We end up with that very same answer. So, let me go again now. I want to be as careful with this as possible because you have 4AC different from minus 4AC. Right? So, minus 63 times 56, you end up with minus 3,528. Yeah? So you have that. Then you yeah. So it work out. Yeah. So remember, if you multiply a minus by a minus, you end up with a plus. Yeah, so figure say that makes sense. I just wanted to be absolutely sure. Right? So now we have a portion of what we need. Oh, big up me, big up me, I know all of my student name that. Yeah. Yeah. Alright, so let me put it back. What I had here originally. I'll put back the part there. Put it back. So let's see what we can do now. We have minus B. We have this. Oh, the marker just start get weak now. Yeah. So, okay. Minus b is minus 23. So we can replace this with minus 23. The b squared is 529, so we can replace this with 529. Now, for semantics, let me put a plus sign in front of that. So the minus 4ac becomes a plus 14,112. Let's make sure it's with a dot. And that's the reason why dealing with the minus sign is so important, because if we weren't careful with this, we'd end up with a minus sign there and we'd end up with a negative number under square root, and there's nothing you can do with that. Well, unless you're going to use imaginary numbers, which that's for a different lifetime. Right. Oh, 2a is minus 126. So I'm going to put that there. Let me not forget that. So this is minus 126. Alright, so now let's write something now. Let us add what is under the square root. 14,641. 14,641. So I can replace this . Yeah, with that. So the good news is, if you square root that, you're definitely going to get a perfect square. So, oh wait, why that number look familiar? That number look familiar. Yeah. Alright, if I square 11, oh yes. I don't know, yeah, mentally I've figured it out. If I square 11, I get 121. But if I multiply 121 by 11, I get 1331. And there's a pattern where you have 11, then you have 121, then after 121 you have 1331, and after 1331 you have 14641. So this is 11 raised to the 4, and if you divide that by 2, it's really 11 raised to the 2. So this, if I square root this, I'm going to get 121. I can guarantee I'm going to get that. Yeah. Square root that, I'm going to get 121. So now I can change this now. Alright, so hold on there. Not, oh boy. Why am I always doing this? Yeah. I was in the middle of trying to replace that. No, what is it gonna look like now? Alright, 121 minus 21, 100 100 minus 2, 98. Okay, so there's one possibility where you have 98 over 126, but it's really minus 126, so there's that. 49 plus 49 is 98. Okay, alright. Then now on the other hand, alright, yeah, 121 plus 23 is 144. Okay, yeah. So the two possibilities is going to be a positive 98 over minus 126 or minus 144 over minus 126. Yeah. I just wanted to know if it could work with a negative a, and it actually worked. It actually worked itself out. I've never done it using the a as a negative before, right? Because usually we're accustomed to having this on the other side and all of that. So I wanted to see if it would work, and it worked. And regardless of how ridiculous the numbers are, you can do what you can do. But yeah, I mean, imagine that. And maybe that is I can give myself some practice with some madness, yeah? So imagine say we need to find out this. What is AC? So I need to multiply 56 by 63, and then I cheat the game by doing this. I like that. I never do my multiplication like this. Oh, here's the second part to this, right? Just so we can make sense of it. So I'm going to write what's here. I'm going to write it down 2 times. So I'm going to write down 60 plus 3 times 60 plus 3. Now, let me just put this in red, just so that that's why I like color code these things, so that we don't get confused with what is happening. So now, my red 50 will go right here, and my plus red 6 will go right here. And what make life nice now is that we just focus one at a time. 50 times 60, well, we have 3,000 for that, so we're done with that. You can all tick them when you're done. So see there, we're done with that one there. Now we have 50 times 3, we'll just say 150. And now we're done with that. So we can move on to the 6 part now. 6 multiplied by 60, we have 360. So we take that part there too. And the last thing now, 6 times 3, we have 18. So then you have this. And no matter how much times you do this, you can't get it wrong. 510 plus 18, 528. And so when you put these together, yeah. And it don't matter what you get. No matter which set of number you get, you can do it just like that. And if that is AC, then you know how to find 4 AC. So all you need to do, add this to itself, and when you get that answer, add that number to itself, and you're done. So even when the number big and ridiculous, and let's say you don't have no calculator, you can do this. So just add this to itself, where you get 7,056, yeah. And then you just add 7,056 to 7,056. So let me put another one up there for the fun and see if that work out. Now mind you, I don't want to use one that's easy. Like I'm not gonna use one that have a 0 at the end, because them one they you know for top your head about that. Once it ends with a 0, you know how easy that is to do. Alright, let me use, we have 35 plus 33 and then now we know what the C is supposed to be, the B and the A. So C is 35, B 33, the A minus 54. Oh, hold on. Move this back. Yeah. So, out of curiosity, if we needed to find AC, and obviously you can put a negative at the end of it, because the most important thing is just multiply the number as is, and then you can worry about the minus sign after that. So, if you want to find out what minus 54 times that is, yeah, you just, oh, look at this. This easy because it ends with a 0. It's alright. So we have 35 times 54. And now we have 30 plus 5 times 50 plus 4. Oh, I forgot to color code it. Alright. 30 here, 5 right there. So I'm going to write this down 2 times. So I have 50 plus 4 here, and then oh, great. Look at that off screen. Ah, there we go. Alright, so this 30 come down here, so and I go move it so we can see it. Right? So we'll put that 30 in front of this. The plus 5 over here. So move that over. And then we do what we did before. This times this, this times this, this times this, this times that. So 15, we have 2 0. This is 120. 250. And then what? 20 at the end. So I make sure I have everything correct now. 5 times 3, 15. 10 times 10, 100. 100 times that, yeah. Alright, so I could do that. So what is now? 370 plus 20, 390. So 1890. Alright, now go ahead and calculate and see if that works. Well, look like it did. So we did get 1890 after all of that. So yeah, look at that. Look on how distributive property come save my life. Yeah. Now, remember now, this part is just AC. So if you want 4 AC, add this to itself, get your answer, and take that answer and add it to itself. Right? Because you're technically multiplying when you do that. 1890 times 2 is the same as 1890 plus 1890. So just add them. Right? So therefore, let me see now. That would have been AC. Then if you add it to itself, hold on, I don't know. Alright, so 1890 would go up to, let me see, 3,780. Then when you add 3,780 to itself, now that would be I'll make sure I said the right thing to put on. 3,780. So I have 7 should be 7,560. Yeah. Some of that. Let's double check all of that. Yeah. So therefore, this is AC. This is 2 AC. This is 4 AC. So yes, you can multiply it by 4. Or you can do this. Add this to itself, get that. Add that to itself, get that. And you get 4 AC. Yeah, man. That's the right thing, that's the right thing, that. Now, the other thing I wanted to do, and obviously I'm going to do more of these later, but probably not going to do all of that today. What may I look for? Right, I was looking for, oh. No, those are, no. Ah, there we go. Oh, yeah. Alright. Let me do one of the crazy ones before I go. Now, so I'm moving from this now to changing the subject to the formula again. So there's one I'm looking at that say 1 over v plus 1 over u equal 1 over that. Then let's say make typically what happens here, and this is something that I guess I learned from somebody at a university, you have a V, you have a U, you have a F. Well, the LCM of all of them is just VUF. So you're going to take the LCM of all of these and multiply it by this and by that. Right? So you're going to put a bracket around this and a bracket around this and multiply the left and the right by VUF. So let me move this back a little bit. And then multiply this by VUF. I'm not sure how I can say all of that. Yeah, alright, good. Now, after this, you start cancelling a few things, right? Make sure I say that no look too. Yeah. Alright. So V divided by V cancel 1 times UF. So this on the left would be UF. U divided by U, VF, VF times 1. This will be, that will be VF. Then now, F divided by F, that will be VU. So now you have VU or UV, whichever one you want to call it. Now, what they wanted from us is what? F. So I go color the thing that I want. So F is what I want. The letter F or common letter F, whatever you want to call it. Now, I can factorize this. Because what they have in common is that letter. So I put that on the outside here. If I divide UF by F, it is just U. And then I divide this VF by F and I would have V right there. Now the nice part about this now is that there's only one more step. One more. I want to get rid of this. So if it is upstairs, it must also be down here. So therefore, what I do to the left, I do to the right. So the grand finale now so let me just and that should be the end of that. Now when you get a little comfortable with them, you can start substituting it back up here, seeing if you can get back the original equation. But yeah, that's some extra work which you don't necessarily have to do unless you want to prove that you have it right. But yeah, this is the last step of it. You could have found the LCM here and then you would have just it results in the same thing, you know. It's the same thing you're gonna end up doing. Because this up here so would have be you'd end up with let me do it another way and see if is 6 or 1/2 a dozen the other, right? Because I'm sure it results in the same thing. Let's say we never know this method at all. Let us assume we never know it. I will do it another way. I will say fine, I could try to simplify this part here, so I will end up with UV. Well, if you divide UV by that, you end up with U, right? End up with V. Yeah, it makes sense. It makes sense. Because now you just go cross multiply. You just go cross multiply. You go multiply F by up here, UV by here. So all you're going to do. So this part going to be F equal U plus V. And UV times 1 is just UV. And you just divide both of them by the U plus V. Yeah, I hit that. I hit the dot to the left. Yeah, done. Done. And I don't know. Yeah, to each their own. Everybody have a different method for that. But this work itself out like lightning fast, because you multiply this F by this. You multiply the UV by that. Because all cross multiplying is taking 2 steps and doing it in one go. Right? That's really what you're doing. Because all you do, you multiply F by the left and F by the right. So you end up with F times this equal 1. And then you just multiply UV by both sides. So it's just a fast forward button. That's really what that is. There might be, so I think what I want to do is continue doing some of these for next time. Well, look and see if there's any other one that you know what, I'm gonna do this one. These are the last one I'm gonna do. I'm gonna do this last one, because sometimes when you see some square root and all the madness there, you have to wonder what you have to do. Alright, so this is a strange looking Y. Strange looking B. And then what now? Aha. Now, to make your life easy, what they want as the subject of the formula, you just color that. You just color what you want. So when they say make that the subject of the formula, you just color that very letter. So the real question is, what we're going to do with this? Why? Okay, so for make your life simple, get rid of this. So multiply this letter by both sides. So if that's the case, if you multiply this by this B and this by that B, you'll end up with and this weird looking Y. And then so B times this, you end up with that. B times this, you end up with 1 times all of that. So this would be now want to get rid of the square, so let's just get rid of it. Square both sides. So you have to square this, but also square that. So that eliminates the square root over this. And then this would be whatever this symbol is. So B something like that. No, this, alright, I thought it was going to be more difficult. I thought it was going to be, but no, we're not make it too tough. We multiply this letter by both sides, so you're going to end up with E times all of that. So let me write what that should look like. And then the right is going to be looking like this. Then now you just divide both sides by b squared y squared. So let me look for it. No. So therefore, cross out this, and I believe that's it. Yeah, that should be everything. So let's see, would this work? If I put that here, yep. Yeah, it actually worked. If I were to divide this by this, I end up with b squared y squared over 2mv times 2mv. The 2mv's cancel, leaving me with b squared y squared. So if I put that under here and I square root that, I end up with by. But by times 1 over b, yeah, I end up with just a y there. Yeah, so this, we'll work more on some of this. So I believe we do enough maths for today. So I will try to post these on the other page, and I need to actually do it. And I'm going to post all the other things that I don't post as yet. So I guess look out for them. And yeah, because I go posting some of them from the computer, some of them from the phone. So it's a madness. So in any case, try to do this in the afternoon every Tuesday, Wednesday, Thursday. So I come alive, hear me go, you see that? I'm tired. I'm tired. So you know what? I'm going to leave before I say anything that sounds like inebriation and intoxication. So this was changing the subject of the formula. I will do more of this tomorrow and Thursday again.